Hello and welcome to another video presentation, courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook, and today's demonstration will be doing the tablecloth pull. Now, this concept has to deal with inertia, and that an object at rest will want to stay at rest unless acted on by an outside force, and the same thing goes with an object in motion will want to stay in motion unless acted on by an outside force. So now, a lot of you have probably seen this done in movies to where we have items on a tablecloth as you see before you, and a waiter comes by and quickly yanks out the tablecloth and all the dishes basically stay on the table. Well, how does this happen? Well, the reason why that happens is because they are overcoming the friction between the objects and the tablecloth, and they're moving the object fast enough the other objects aren't able to respond to it. Now, one little detail that they never tell you about, and it's never explicitly stated, is when they do the tablecloth pull, you need to remove the edge. You can't have a pronounced, sewed edge together, because otherwise it's going to create a little bit of a difference of height. And that mass is now going to interact with your object. It's going to hit it and it's going to move it. So this tablecloth pull can only really be done if you have no prominent seamed edge on your tablecloth. So now with this, we should be able to just say, I've got a floured base, I've got this candle, and I've got another candle. And this candle in the middle has some rocks below it, and I should be able to pull this tablecloth because of the concept of inertia fast enough for these objects to not respond. It's the same way as that if you had a stack of bricks and you were to cut out the middle one quickly, you'll be able to have just the rest of the bricks fall. It's because you're moving fast enough, you're overcoming the coefficient of friction, and it's not able to respond as well. So now, with this and the knowledge that we have, I need to pull this cloth very fast. If you notice, if I pull very slowly, the objects move. That's not going to be good. So that just tells us, oh hey, if I'm pulling slowly, the objects have a chance to interact with each other, the coefficient of friction is high. Whereas if now I move this very quickly, instead of static friction, the kinetic friction is going to be less, and I'm able to move this without the objects being able to respond as fast. So now, I've got the tablecloth. So you might have said, Corey, you were doing this on the very edge and not on other spots. Well, that is true, because this tablecloth is not perfect and has a lot of wrinkles, as you can possibly see. It's been folded. So as soon as a wrinkle occurs, it causes it to fall over. So let me do that demonstration of why it's really important to have a nice, ironed, flat tablecloth. So now I'm going to put this right in the middle. I see a nice clear crease here. So now I'm going to try to do the same speed, and you're going to notice that this base is going to hit this wrinkle, and it's going to fall over. This is why it's so important to understand how the inertia works and how that little bump has mass. It's now moving, it's now accelerating. It acts like a force, it acts like a collision with the glass, causing it to tip over. So that's, again, very important why if you're trying to do the tablecloth pull at home, you must want to look at the edge of the tablecloth first, and then look to see how wrinkled that tablecloth is. Well, thank you for listening to this video presentation, and have a wonderful day.